What ethical dilemmas do autonomous robots face in crashes? Imagine a robot driving down a busy street when suddenly a child runs into its path. The robot must decide whether to swerve and risk hitting a wall or stay on course and possibly harm the child. This kind of split-second choice highlights some tough questions about ethics and autonomous systems. Autonomous robots, especially those used in vehicles, are programmed to avoid collisions using sensors and algorithms. But when a crash becomes unavoidable, they face decisions that humans would find morally challenging. One big issue is how these robots decide who to protect first. Should they prioritize saving the passengers inside the vehicle or the pedestrians outside? If the robot has to choose between hitting a group of pedestrians or the driver, how does it make that call? These decisions involve balancing harm and trying to minimize damage, but they also raise questions about fairness and moral responsibility. Another dilemma is who is responsible when a crash happens. Since autonomous robots make decisions based on their programming, it's not always clear who should be held accountable. Is it the engineers who designed the system, the company that made the robot, or the owner who is using it? This gray area makes it hard to assign blame and creates legal challenges. Programming ethical values into these robots is also a tricky task. Should the robot be programmed to save the greatest number of lives, or should it protect its own passengers at all costs? Or maybe it should avoid harming vulnerable groups like children or the elderly. These choices reflected human moral values, but different cultures and individuals might have different opinions on what is right. There's also the question of whether the robot's behavior should be controlled by the designers or the users. Should users be able to set their own ethical preferences, or should the system follow a standard moral code? Giving users control might make the system more personalized, but it could also lead to inconsistent decisions and unfair outcomes. Robots often operate in unpredictable environments with incomplete information. They must make ethical choices without knowing everything about the situation. For example, if a pedestrian suddenly steps into the street, the robot has to decide quickly whether to brake hard or swerve, risking other accidents. These decisions are made under uncertainty, which complicates applying simple ethical rules. Legal rules also lag behind technology. Current laws assume humans are in control, but autonomous robots learn and adapt over time. This makes it harder to create regulations that ensure safety and moral responsibility. Policymakers are working to develop new frameworks that balance innovation with ethical standards. All these factors influence how collision avoidance strategies are designed. Engineers try to embed ethical decision-making into the algorithms, so robots can weigh potential harm, likelihood of accidents, and environmental context. But it's a complex task that involves not just technology, but also ethics, law, and societal values. In the end, autonomous robots face tough moral questions in crashes. They must be programmed to make fair and safe decisions, while responsibility and accountability are shared among designers, manufacturers, and users. Developing these systems requires careful thought and collaboration across many fields to build trustworthy and ethically sound autonomous systems.